in the moment generating function also we can learn in the first unit, in the third semester also define the rectangular distribution, moment of a distribution, Qness of curious of distribution. There is the moment generating function. We can learn this one. What is the rectangular distribution? What is the rectangular or uniform distribution? So both are same here. So a random variable x is said to be a continuous continuous distribution on interval a comma b about the probability density function of the container. So in the probability density function of PDF, so in the PDF we have taken here k a less than x less than b, so 0 otherwise. So if the less than function, then the normal rectangular distribution or uniform distribution, so the probability is always is unity. So unity means is the one integration of a to b. So integration of a to b f of x dx is equal to 1. So integration of f of x, that means integration of a to b k dx. Integration of a to b k dx is equal to 1. So integration of dx, integration of k is constant. So integration of dx, tell me. Integration of dx. వినబడుతుందా అండి నా వాయిస్? హలో 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 ఓకే. So integration of k, integration of dx means x. So x lower limit a and upper limit b, I am substituting 1. So therefore k is equal to constant. We are substituting the values. And also k into b minus a whole power a. So that is a b minus a. I am substituting here. That is a k is equal to 1 by b minus a. So why? Because we are applying here. So b minus a we are taking. That's the left side. B minus a. That's all. That is a minus a. We are b minus a we are taking here. So that the condition we are taking here. So that is a k is equal to 1 by b minus a. We are taking the condition. So therefore f of x is equal to 1 by b minus a. F of x is equal to 1 by b minus a less than x less than b. So the condition we are taking here. So what is the condition here? Rectangular or uniform distribution is the same here, less than of the 0 of the condition, 0 otherwise. So a and b are the two parameters we are taking the uniform distribution or rectangular distribution. So x equivalents to u of a comma b. So probability density function here also we are taking the same here. So f of x is equal to 1 by b minus a. The condition is same. A less than x less than b. So 0 otherwise. So therefore, in the clearly first function we are taking here f of x greater than or equal to 0. That is condition integration of minus infinity to infinity. Integration of minus infinity to infinity in place of f of x we are taking here is equal to 1. So integration of a to b, f of x dx is equal to integration of a to b, 1 by b minus a. So therefore 1 by b minus a, what is the condition we are taking here? So that is a 1 by b minus a, we are taking the constant from the outside here. So integration of dx is x. So upper limit and lower limit we are applying here. So a to b, so b minus a. But first we are applying upper limit b, then minus a low upper limit b minus a by b minus a. So therefore b minus a by b minus a is equal to 1. So f of x is probability density function as the condition is satisfied. Second one, the distribution function of the uniform distribution or rectangular distribution of the same. The distribution of the function can be defined as f of x of x. The base f of base of x is equal to p x less than or equal to x. So integration of, already I told you, integration of minus infinity infinity f of x dx is equal to 1. But even though integration of a to x f of x dx, so the value we can learn that integration of a to x 1 by b minus a dx. So see here 1 by b minus a x 0 to 1 by b minus x, the lower limit and upper limit xa. So we can write here x minus a. So 1 by b minus a we are writing, that is x minus a by b minus a. So f of x 0 minus infinity less than x less than a. X less than a. So x minus a by b minus a, if a less than or equal to x less than or equal to b. So one is the condition if b less than x. So condition is a less than or equal to x less than minus infinity less than x less than a. So if a less than or equal to x less than or equal to b, both the conditions we are taking here, but one also taking b less than x less than or equal to. When f of x stands to x, we are taking here. So see, since f of x is not continuous, x is equal to and x is equal to b is not differentiable at these points. It's not differentiable, it's not equal. So it's compulsory is a differentiable we are taking here. So then d by dx of f of x is equal, then f of x is equal 1 by b minus a not equal to 0. In the denominator, if the denominator is not equal to 0, so that the value should become, if the denominator is equal to 0, and the denominator, if the denominator is equal to 0, the value is 0. So b minus a not equal to 0 exists every expect the point x is equal to and x is equal to b. Consequently, f of x is given by, but see the diagram, all of you. See the diagram of all of you. See here, our f of x is equal to 1 by b minus a. So that the condition a to b x we are taking here. In the another way, f of x a to b is a one angle we are taking. There's a figure 2 we are taking, the figure 1 and figure 2. For a rectangular distribution, variance of the x a minus a. So what is the minus a? From x axis to y, left side to right side, minus of a to a. In x axis, the period probability density function is given by f of x is equal to 1 by 2a minus a less than x less than a, minus a less than x less than a, 0 otherwise. So the conditions what we are taking here for the uniform distribution. So moment rectangular distribution, what we are taking here. So in the moment rectangular distribution, the most important, the non-central moment and central moments learned in the first and second, third semesters. So the non-central moments is the moments of about the origin. What is the origin means? We are taking the point of the origin in the 0. So therefore, we are taking mu r dash is equal to ex power r. So that is a condition of integration of minus infinity to infinity x dash of x dx. So in place of f of x, the probability density function is corresponding to the distribution. So mu r dash is equal to integration of a to b x power r. So therefore 1 by b minus a dx. So 1 by b minus a dx, x belongs to ab. So 1 by b minus a dx means what we are taking, the condition taking here 1 by b minus a lower term and upper term. So lower term is a and upper term is b. So if x belongs to ab, we are taking here. So in the same condition 1 by b minus a, so x power r plus 1, x power r plus 1 by r plus 1, the condition we are applying here in the lower limit a and upper limit b. So we are applying here 1 by b minus a. In place of x, we are applying b here. So b power r plus 1 minus a power r plus 1 by r plus 1. The condition is, the strike off is given, but the condition we are applying the same here. In particular, put r is equal to 1 in one mean. First mean we have to find it. Mean is equal to mu1 is equal to 1 by b minus a. What is the condition? Is b square minus a square by 1 plus 1. So what is the condition in place of 1? What is equal to r is equal to 1 in place of b in the above equation? B r plus 1 means b 1 plus 1 means b square minus a power r plus 1. And a power 1 plus 1, that is 2 square. In the denominator r plus 1, 1 plus 1 is equal to. So b square minus a square by b minus a into 2. So b square minus a square we can write here in b plus a and b plus a and b minus a. So in the fundamental formula b plus a and b minus a, the both the multiplication we have to do here, b square minus a square. So therefore condition the b minus a and b minus a should be cancelled here. So therefore b minus a cancel. That is equal to mu in is equal to b plus a by 2. There put r is equal to. So r is equal to 2. What is the condition we are taking here? Put r is equal to, we said mu 2 is equal to 1 by b minus a, b cube minus a cube by 3. So therefore b minus a by b. So b minus in b cube minus a cube formula, a cube minus b cube formula, we are writing here the same condition. So b minus a, why we had, I am taking b minus a. The denominator b minus a is there. So the we can cut it, the numerator and denominator should be cancelled, b minus a. So b square plus a square plus ab. The plus is missed here. B square plus a plus ab. So b minus a should be cancelled in the numerator and the denominator. So therefore b square plus a square plus ab by 3. There is a mu 2. Then put r is equal to 3. So r is equal to 3, what? Where mu 3 dash is equal to b power 4 minus a power 4 by. So b minus a into whole power 4. There is no cancellation here. So therefore, so one cancellation here. B square plus a square by b plus a by 4. So b minus a should be cancelled here. B plus a into b minus a. So b square plus a square into b plus a and b minus a should be cancelled here. Put r is equal to 3. So there is a mu 3 dash. We are taking the value mu 2 mu 3 dash. So r is equal to 4. Mu 4 dash is equal to 5 by a power 5 by 5 into a minus b. So there is a condition mu2 dash and mu1 dash. Mu2 is equal to mu2 mu1 dash. So there is a conditions what we are applying here, b square plus a square plus ab by 3 minus b plus a whole square we are applying here. These conditions applying here. After the simplification, that is a minus b whole square by 12. See these conditions you have to LCM, do the LCM here. I'm audible, all of you? Yes, I'm audible. Yes. Okay. A minus b whole square by 12. So the variance is e power x, that is a minus b whole square by 12. The central moments of for uniform distribution we are discussing here. Then the central moment, the orth moment about the mean or central moments, we are writing mu or e of x minus e of x whole power r. So e of x is mean, e power of x is variance. Earlier we can discuss here. So e of x, e power x means already variance. We have find out the b plus a by 2. So there is a whole power r x is x equals to u of a comma b. So therefore integration of a to b x equals to b plus a by 2 whole power r, that is we are applying f of x dx. Why? Because e of x equal integration of a to b x f of x dx we are taking. So integration will be x minus b plus a whole by 2 whole power r. So f of x dx we can simplifying here f 1 by b minus a, we know that. So dx means we are already returning as it easily dx. 1 by b minus a integration of a to b. So we are taking here 1 minus b by a constant. We are taking the left side here. So integration of a to b x minus b plus a by 2 whole power r dx. So let us use the transformation. So y is equal to x minus b plus a by 2. So what we are taking here, what we are doing here, the condition what we are taking here, y is equal, the condition transformation, the y x minus b plus a by 2, that is dy is equal to dx. So limit c if x is equal to a. Limit c if x is equal to a by applying y a minus in place of x in place y a minus b plus a by 2 only in x place. What, where is the x we are applying a minus b plus a by 2, that is minus 2a minus b minus a. So that is we are writing cancellation of these ones. 2a plus a, that is minus b minus a by 2. So minus of b minus a by 2, we are writing, we are calculating that minus c. C, it's a b plus a by 2c, but in front of minus c is there. So we are writing that is minus c here. So therefore x is equal to b, therefore y is equal to b minus a by 2c. So therefore mu r is equal to 1 by b minus integration of minus r minus c y power r dy. If the odd numbers 1, 3, 5, 7, we can take that there's odd numbers, and the odd numbers we are taking here. Then mu1, mu2, mu3, then the odd numbers means automatically mu1, mu3, mu5 is equal to 0. Then since mu1 is equal to 1 by, already I told you 1 by b minus integration of minus c to c at the base, lower limit and upper limit, we are taking here y dy. So y dy we are differentiate after that 1 by b minus integration of minus c to 0 of y dy plus integration of 0 to c y dy. So I'm taking the both the integration minus c to c, I'm dividing the both the derivation 1 minus c to 0, 0 to c. So upper and lower limits are I'm separating here. So both the integration of minus c to c. So both integrations of minus c to c we are taking here. So in minus c to 0 and 0 to c we are taking here. So 1 by b minus a. So integration of y dy. So y dy means you know that integration of dy is y, but integration of y dy is equal to y square by 2. That's basic condition lower in the upper limit minus c comma 0. And integration of y dy y square by 2 and 0 to c. So 1 by b minus a in place of y square by 2, I'm applying 0 by 0 is 0. And lower limit I'm applying here. So minus e, already inner 1 minus is there. So a minus b. So inner 1 minus is there, that minus and this minus you should apply, that's a plus. So 6 square by 2 minus, and minus is y square by 2. The c is the upper limit, so that's why directly I'm writing c square minus by 2. So both the c square minus c square by 2 minus c square by 2, both the equations will be cancelled here. 0 into something is 0. Similarly, mu3, mu5 also 0. So mu1, mu3, mu5. What I am telling you, 1, 3, 5. Odd numbers should be 0. So mu1 we have to done here 1, 3, 5 condition. You have to do the same mu3 and mu5 is equal to 0 also same. So r is equal to 2, 4, 6 integers we are taking here. I'm audible, all of you please. Yes, please. Yes, I am audible. I am audible. Uh, So R is equal to 246, mu 2, mu 3 is equal to 0. This is also 0, mu 246, mu 1, mu 1, mu 3, mu 5. 246 also, even it is a mu r 1 by b minus a, integration of minus c to c y 4 by power r. So y power r dy, so 1 by b minus a. So 1 by b minus a. So what we are taking integration of minus a. Earlier condition we can take c square by 2. That is a, so that is the conditions we are to 246. First we are taking here 2. So 2 is condition is constant. We are taking a 2 integration of 0 to c y power r dy. So 1 into 2 by b minus a. So therefore 2 by b minus a, we are applying y power r. Y power r means y dy means y square by 2. So y power r means y power r plus 1 by r plus 1. So c is equal to what is the condition is b minus a by 2 0. So 2 into b minus a by 1 by r plus 1. I am separating y power r plus 1. I am separating here 1 by r plus 1. That is y power r plus 1. I am taking here. In place of y power r plus 1, I am taking a b minus a. Y means b minus a. So y is b minus a by 2. Then r plus 1 we are taking here. So therefore 2 into b minus a. So simplifying 2 into b minus a r plus 1 by b minus a into r plus 1, 2 into r plus 1. So again condition b minus a whole power r. So therefore r plus 1 whole power 2 power r. So therefore mu r is equal to b minus a whole power r by r plus 1. That is into 1 by 2 r. The condition that we are applying here. Now, now we are applying here. Now we are applying here the condition 246. The basic condition we are applying here 2 here. So mu 2 is equal to formula is b minus a whole power r. But in place of r, we are applying here 2 b minus a whole square. Or in place of r, 2 plus 1 by 1 plus 2 whole square we are taking here. See here. So b minus whole square by 12. So therefore, what is the fundamental formula? I already told you in the beginning of this class. Mu4 is equal to b minus a whole power 4 r plus 1. That is r means 4 plus 1. That is 1 by 2 power 4. B minus a whole power 4 into 4 plus 1, 5 into 2 power 4. 16 into 5. 2 to the power of 4, 16 into 5, 80. So the uniform distribution of the skewness as follows here. The coefficient of skewness b1 mu 3 square by mu 2 square. Something is value is 0, but nothing but beta 1 is equal to 0. The uniform distribution is symmetric. And the coefficient of kurtosis, the coefficient of kurtosis. Okay. The coefficient of kurtosis b2 is equal to mu 4 by mu 2 square. So therefore, mu 4 formula b minus a whole power 4 by 80. That is b minus a whole square by 12. So there is a values you are applying here. There is 1.8. So beta less than 3. So uniform distribution follows platykurtosis. The platykurtosis you learn in the second semester and the third semester also. You have to, that kurtosis less than is that the uniform distribution follows platykurtosis. Then moment generating function. MGF, already I told in the third semester also, what is the MGF moment generating function? So x equals to union of a comma b. The moment generating function. What is the moment generating function? X is defined by m of x of t e power of etx. So e of e power of tx, what we have integration of minus infinity to minus infinity to infinity, e power of tx f of x dx, where f of x is a probability density function is a uniform distribution here. So therefore, m of x t is equal to integration of a to b etx. So the condition that is f of x, we know that 1 by b minus c into dx. So 1 by b minus c is the constant function. We are taking the common part here. 1 by b minus integration of a to b e power tx dx. So e power tx is the basic, the integration. What's the value you have to do? You have to integrate here. The same has been we are integrating here. So 1 by b minus c is a constant. We can take the left side here. And the e power t, integration of e power tx is e power t. So e power 100 also e power 100. So therefore integration of e power tx by t. And that x is a variable. So e power tx by t integration of that is a condition a to b we are taking here. So 1 by b minus a e power e 1 by e b minus a e power bx by t. So see the earlier condition here, e power means e power bx by a condition what we are doing here. So e power bx by t minus e power ax by 2. This is a required moment generating function of the distribution. This one. Any doubts of this first unit? Ask me doubts, please. Hello? Hello?
Doubts, sir.
Tawni, are you okay?
Yes, sir.
Okay. Shall go to the second part. You can clarify any doubts. Ask me that in this interest. Show that the uniform distribution is symmetric distribution. Main question is define uniform distribution for mean and variance. First and three questions, short questions are important. And the long question, show the uniform distribution is a symmetric distribution. And find the beta 1 and beta 2 uniform distribution. These are most important. Clear? Clear? Any doubts?
Yes, sir.
Okay. The first unit is audible. First unit winabadada. Hello?
Sir. Yes, sir.
Okay. The normal distribution one. So the most important unit, normal distribution. So the normal distribution is very most important unit. The third or fourth semester, this will be useful in the fifth and sixth also. So mode of the normal distribution, median of the normal distribution, moment generating function of the normal distribution, additive property for normal distribution, characteristic function of normal distribution, cumulative generating function of normal distribution, central moments and normal distribution, mean deviation of the mean and normal distribution, points of inflection of normal curve. These are most important. These are most important topics in this unit. What's the objects here we have to learn here? Define the normal probability distribution, obtain the mode and the median of the distribution, find the moment generating function, derive the characteristics function, find the moments of the distribution, use cumulative generating function, find the mean and the variance of the distribution. What is the cumulative means? Cumulative means LCF and GCF, lowest cumulative function and greater cumulative function. So LCF, what we have to do, top to from the up to down, and GCF is from down to up. We are doing here. So there is an integrity. This is the LCF and GCF we are doing here. The cumulative generating functions. So normally probability distribution is commonly called as the normally distribution. So here normal probability distribution. Normally probability distribution called as also normally. Normal distribution is the one of the most important continuous and theoretical distribution statistics. Most of the data relating to the economic and business statistics or even social and physical sciences come from to this distribution. So I'm not going to the theoretical part. There is no short bits in your main examination. So directly I'm explain what's the normal distribution here. So definition. So a continuous random variable x is said to be normal distribution. And x is a normal distribution. The parameters of mu and the sigma square, that the probability density distribution. X mu sigma square. Mu, what is the mu means? Mean and standard deviation. There is a formula. Variable, mean, standard deviation, 1 by the root of 2 pi into sigma. That is expectation of minus 1 by 2 x minus mu sigma whole square. So therefore, x of mu sigma square, what we are taking here, and the condition of 1 by half root 2 pi of sigma, 1 by root 2 pi of sigma e power, there is a condition of formula, e power minus 1 by 2 x minus mu whole square by sigma. What is the why we are taking here? So that we are telling continuous random whole variable x is said to be normal distribution. So that's why we are taking here expectation of minus 1 by x minus mu by sigma whole square. If that is a condition is minus infinity less than x less than infinity, so minus infinity less than mu less than infinity. So ikkada variable తీసుకుంటున్నాం, mean తీసుకుంటున్నాం, standard deviation. ఎందుకంటే మనం కండిషన్ రాసాం. We are written in the condition x comma mu comma sigma. So we are returning here minus infinity less than x less than to infinity, minus less than mu less than infinity, sigma square greater than 0. So clearly we have to take that the f of x greater than or equal to 0. Why we are taking greater than or equal to 0? Equal to 0 కావచ్చు or greater than equal to 0 కావచ్చు. So first the condition we learned that in the earlier the first unit, integration of minus infinity to infinity, there is a condition f of x dx equal to 1. So b minus a, what the condition we have written here. But in this problem, integration of minus infinity to infinity f of x dx, is equal to minus integration of minus infinity to infinity 1 by under root of 2 pi sigma. So e power 1 by 2, that is x minus mu whole square by sigma, that is a dz. We are taking that, what conditions we are taking. Let us use the transformation. What is the transformations of we are taking here? X minus mu by sigma. Already we can take x mu and standard deviation. So standard deviation and the mean, both the parts we are taking here. But first we can take the mu and standard deviation here. X minus mu by sigma is equal to z. So x is equal to sigma into z. The cross multiplication we are doing here. So z into sigma z. So minus mu, go to the right side here, plus mu. So there we can differentiate here d of x. Dx is equal to with respect to dxx. Dx is equal to sigma into sigma is constant. Dz, the mu is constant. Here is equal to 0. So integration of minus infinity to infinity. So we are integration of minus infinity to infinity f of x dx. So what is the condition we are taking here? F of under root of 2 pi sigma minus infinity to infinity integration lo e power of minus 1 by 2 z square. Here sigma dz వచ్చింది అక్కడ రాస్తున్నాం. సో 1 by root pi sigma ఇక్కడ రూట్ లో సిగ్మా లేదు గుర్తుపెట్టుకోండి. రూట్ లో సిగ్మా లేదు గుర్తుపెట్టుకున్న సిగ్మా గెట్ క్యాన్సల్ హియర్. సో ఈ ఇంటిగ్రేషన్ మైనస్ ఇన్ఫినిటీ ఇన్ఫినిటీ minus 1 by t స్క్వేర్. సో z స్క్వేర్ బై t. సో ఇక్కడ ఏం చేస్తున్నాము? z స్క్వేర్ బై 2 ఇక్కడ మీద రాసాము. z స్క్వేర్ ఇక్కడ మీద ఫార్ములా ఐఎమ్ జూమింగ్ హియర్. మైనస్ z స్క్వేర్ బై 2 ఉంది ఇక్కడ. సో మైనస్ z స్క్వేర్ బై 2 ఇజ్ 2 t అనుకున్నట్లయితే, ఎందుకు అనుకుంటున్నాం t అని మనం ఒక తీసుకున్నట్లయితే z స్క్వేర్ ఇజ్ ఈక్వల్ t. సో డిఫరెన్షియేట్ చేస్తున్నాను నేను. 2z dz is equal to 2dt. Both side differentiation I'm doing here. There's a normal distribution here. See here, dz is equal to dt by z. So dz ఇక్కడ చూడండి ముందు దానిలో ఇక్కడ ఏం రాసాం? Just a minute. Two z dz is equal to 2 dt. So దీన్ని సింప్లిఫై చేస్తున్నాం ఇక్కడ. dz is equal to dt by dz. dt is equal to under root of root t. అందుకే dz లోనే కండిషన్స్ అట్లానే అప్లై చేస్తున్నాం. సో therefore integration of minus infinity to infinity f of x dx is equal to 1 by under root of 2 pi. So integration of minus infinity to infinity we are taking here e power of minus t. So 1 by t. So what minus infinity to infinity we are taking here that condition. So e power minus t of earlier that condition, and the 1 by root 2 dt, 1 by root 2 and 1 by root t. That is 1 by root 2t into dt. So we are writing here 1 by root 2 pi, and again 2. We can 2 we are taking here. Integration of 0 to infinity 0 power minus t 1 by root 2 and 1 by root 2 dt. So why we are taking here in that ఇంతకు ముందు వచ్చిన దాంట్లో ఇక్కడ చూడండి, ఇంతకు ముందుకు వెళ్ళిపోతున్నాను. ఇక్కడ చూడండి 2z dz లో మనకు 2 వచ్చింది ఇక్కడ కూడా. సో అది వాడుతున్నాను నేను ఇక్కడ. సో 1 by root pi integration of 0 to pi e power minus t plus into t power 1 minus t, both powers లో t power minus 1 by 2 my లో నుంచి నేను 1 by root pi. So therefore e power r into, so that is a simplification of integration of 0 to power minus t. After simplification, r into power 1 by 2. Applying the same here, root pi 1 by 2 into r by 2. So therefore we are applying r is equal to root pi here. So r into 1 by 2. So the here integration of minus infinity to infinity equal to 1. So x follows as normal distribution with parameters mu comma sigma square, and also the mathematically sigma square infinity less than mu less than infinity, sigma square greater than 0 we are writing here. Then mode of distribution. Mode is the addition of f dash x equal 0 and f double dash x is equal. So f dash x is equal to 0 and f double dash x is equal to the first and second derivations should be 0 here. So the probability density function of the normal distribution, already I told you in the normal distribution of this one, f of x is equal to 1 by under root of 2 pi into sigma into e power minus 1 by 2 x minus mu. So e basic is e power minus 2 x minus mu by sigma square. It's a condition in minus infinity less than mu less than infinity. So minus infinity less than x less than infinity. So variables what we are taking here, the condition x minus mu minus sigma, we are taking the conditions here. To get mode value, take log both sides of the difference with respect to one equate is 0. So log f of x, I'm applying here both sides, I'm applying log here. Log 1 by root pi sigma e power 1 e power minus 1 by 2 x minus mu sigma whole square. So therefore log 1 by 2 pi root sigma plus log. So I'm separating. The log is multiplication part is that we can divide that both one. It is a plus. If the minus is there, we can go to the denominator part. Log 1 by root 5 into sigma plus log e power minus 1 by 2 x minus mu sigma whole square. So therefore, we are taking here this condition here. Log under root log 1 by root 2 pi into sigma. So that is the condition is log 1 minus under log root pi minus sigma minus 1 by 2 sigma square x minus mu sigma square. See again here. This is a log, this is a log x I'm treating here, 1 by this is a log 1, and we are separating here 1 by the simplification of 1 by 1 we are doing here. Log f of x is equal to log f of x equal log 1 is equal to 0 minus log 2 pi root 2 pi into sigma minus 1 minus 1 by 2 sigma square x minus mu x minus square. So therefore now difference with respect to x and equating 0 here. So differentiating means what we are doing here, d by dx of log f of x. So d by dx of log f of x is equal d by dx of minus log under root of 2 pi sigma minus 1 by 2 square. 1 by 2 square, 1 by 2 sigma square is constant here. So d by dx of x minus mu square. The constant we have to write in the front before the derivation part. So therefore, a 1 by f of x, log d by dx of log f of x is 1 by d by dx of x. First, we are taking log f of x is treated as x as per the chain rule. So d by dx of x, d by dx of log x is 1 by f of x. Again, that the log f of x, d by dx of f of x is equal the first derivation f dash x is equal to 0. So d by dx of minus log d by dx of that one 0. There is no part minus 1 minus of 2 sigma square. Then again the root will be cancelled. The constant is 2 here. Then x minus mu into there is a x minus mu here. So therefore the another condition is directly 1 by we are taking it with respect to the x, and the other parts is we are taking 0 d by dx of 2 minus x minus mu is equal to 1. So that after the simplification 2 to get cancelled here 1 by sigma square x minus mu we are taking it. The first derivation f dash x is equal to 1 by sigma square x minus mu of f of x. So therefore f dash x is equal to, so almost we are substituting the values is equal to 0. So therefore x minus mu is equal to 0. So therefore x is equal to mu. So we are for x minus mu is equal to 0, then x is equal to mu. Then f double dash x we are taking here. So in f double dash, the second derivation part we are doing here. D by dx of minus 1 by sigma square x minus mu by f of x. So what is the first derivation we have completed? X minus mu we did not take here. What is the f dash x value is 0. But what is the previous part came here? Minus 1 by sigma square x minus mu into f of x. We are taking minus 1 by sigma square is the constant value we are taking in the right side here. So therefore minus 1 by sigma square we can take in that. So f of x and plus x minus mu into the second derivation f of x is the set. The again derivation we are taking here, that is f dash x. So minus 1 by sigma square f of x is x minus mu. So f dash x the value already came. We are writing f dash x value here minus 1 by sigma square x minus mu into f of x. So minus 1 by sigma square, we are taking the f of x is constant from the both equations. So f of x is constant and taking the outside here for the common here f of x. Right here 1 minus x minus mu by sigma whole square. So all the point we can take in all the point x is equal to mu. So we are taking here f double dash x is taking here minus 1 by sigma square. So therefore f of x 1 minus 0. Why 0? So d by dx of that is the value. We are applying here the x is equal to mu minus mu. So in place of mu applying here in the x minus mu minus, see here, mu minus mu sigma 0. 0 in something is 0. 1 minus 0 is equal. So 1. So therefore we can write here 1 by minus 1 by sigma square f of x. So x is equal to mu, the basic condition we are taking here. So minus 1 by square and root of 2 pi into sigma. So basic condition e power of minus 1 by 2 x minus mu whole square x minus, we are applying that value x e power x by x minus m mu by sigma whole square, x is equal to mu. We are taking. But then another condition we are taking here minus 1 by sigma square, that is 1 by root 2 pi into sigma. So minus 1 by sigma square. The sigma is not in the root. We are taking the outside 1 by sigma root pi less than 0. ఎందుకంటే అన్ని values continue కాబట్టి less than 0. X is equal to mu is the mode of the normal distribution. Any doubts? Ask me, I will clarify. Clear? Yes, please.
Yes, sir.
Yes. Okay.
Yes, sir.
So median of the normal distribution here. So median of the normal distribution x equivalents to n of mu sigma square. Here also we are taking minus infinity less than mu less than infinity. But here we are taking the median. Median means sigma square greater than 0 we are taking here. So the probability of the density function of the PDF of normal distribution is given by f of x 1 by under root of 2 pi of sigma e power of minus 1 by 2 x minus mu by sigma whole square, the basic fundamental formula for the normal distribution. The normal distribution is equal to E of x is equal to mu. You already know that if m is the median of the normal distribution, the total class can be divided into two equal parts. So therefore, one is integration of minus infinity to infinity f of x dx. Value is 1. Why? Because 1 by b minus a. Am I correct or not? Hello?
Sir.
Yes. Yes. So I'm applying in place of minus infinity to m f of x dx plus integration of m to infinity. That is minus infinity to infinity. Then first unit lo minus integration of minus c to 0 and a plus integration of 0 to c. So minus infinity to infinity, 0 to infinity. So therefore here also we are taking the same minus integration of minus infinity to m f of x dx plus integration of m to infinity f of x dx is equal to 1. Both the values we are. So both the parties we are bifurcating here. So by in the bifurcate of the parting in the parting, so the lower limit and upper limits will be changed. The first part is minus infinity to m and second part m to infinity. Both the values adding, that is minus infinity to infinity. So the first one minus integration of minus infinity to m 1 by root pi sigma e power minus 1 by 2 x minus mu sigma whole square into dx plus integration of m to infinity 1 by root 2 pi e power minus 1 by 2 x minus అంటే మనం వాల్యూస్ అప్లై చేస్తున్నాం అక్కడ రెండిట్లో. So therefore integration of minus infinity to m. So 1 by root pi of sigma here. So therefore e power of both అన్ని కలిపేస్తున్నాను నేను ఇక్కడ e power of minus 1 by 2 x minus u whole square by sigma. అక్కడ ఇక్కడ కలిపి చేసేస్తున్నాం మనం, రెండు కలిపి సింప్లిఫై చేసేస్తున్నాం దానం. So that is 1 by 2. So integration of m and infinity also 1 by 2. So therefore now consider the integral here 1 by root 2 pi sigma integration of minus infinity to m e power minus 2 x minus mu by sigma whole square dx is equal to 1 by 2. So both are the values are I am applying 1 by root 2 pi sigma. So 1 by root 2 pi sigma I am taking the common here. 1 by root 2 pi sigma I am taking the common here. So therefore integration of minus infinity to mu, that is minus 1 by 2 of x minus mu whole square of dx. The integration of mu to m e power minus 1 by 2 x minus mu whole square by sigma. రెండిట్లో ఉన్నటువంటి కామన్ పార్ట్ 1 by root 2 పైన బయటికి తీసుకొచ్చి రెండింటిని కలుపుతున్నాను. అది 1 by 2 కి ఈక్వల్ గా 1 by 2 రాస్తున్నాం రెండింటికి కలిపి. సో సీ ద నెక్స్ట్ కండిషన్ హియర్ టేకింగ్ ద ఫస్ట్ ఇంటిగ్రల్. వాట్ ఇస్ ద ఫస్ట్ ఇంటిగ్రల్ హియర్? ఇస్ ద మోస్ట్ ఇంపార్టెంట్ in your examination also. That is the 1 by root 2 pi sigma, that is integration of minus infinity to mu e power minus 1 by 2 x minus mu by sigma whole square into dx. So in this part we are taking here x minus mu by sigma is equal to z. So So therefore, in the limits, what is the limits here? Minus infinity and z is equal to minus infinity. So minus infinity to minus infinity, x is equal to mu and z is equal to 0. So what I'm applying here, the same conditions here. 1 by the root of 2 pi into sigma. So in integration of 0 minus infinity to 0. So my x2z, what we have to take in here, e power minus 1 by 2 z square sigma z. So both sides, the sigma is not under the part of root. So I'm cancelling the sigma and sigma here. So therefore 1 by root 2 pi integration of 0 to minus infinity to 0 minus 1 by 2 z square dz. But we know that minus integration of minus infinity to infinity e power minus 1 by 2 z square dz is equal to root 2 pi. So by symmetry, what's the meaning of symmetry? The both are equal. What is the big meaning of symmetry? Hello?
Equals.
Equal. Very good. So by symmetry, integration of minus infinity to 0 e power minus 1 by 2 1 by 2 z square. The condition what we am applying here, that is root 2 pi by 2. So substitute the equation, the 1 by root pi into root 2 pi by 2. Root 2 by cancel it, that is 1 by 2. So under root 1 by and the root of 2 pi sigma, integration of minus infinity to mu e power minus 1 by 2 x minus u whole square sigma whole square by dx is equal to 1 by 2. Substitute in equation 2 and we can get the values here. See here. So 1 by under root of 2 pi, the root of 1 by under root of 2 pi sigma. Integration of already I told minus infinity to infinity, but we are taking minus infinity to m and minus infinity to that conditions. So both the conditions we are taking here. Integration of minus infinity to mu e power minus 1 by 2 x minus mu whole square by sigma square into dx. 1 by root 2 pi into sigma. Integration of mu to m. That means minus infinity to m e power minus 2 x minus mu whole square by sigma into dx is equal to 1 by 2. So that is a simplification of that the above part. See here, there is a 1 by 2, the first condition we are taking here. 1 by root 2 pi sigma integration of mu to m. So e power 1 by 2 x minus mu sigma whole square into dx. Already that part I am writing as it is here, the 1 by 2. So that is after the simplification, we are simplification applying these values here, mu and m. So mu and mu is 0. So mu and mu is 0. E power x minus mu whole square by sigma dx is equal to 1 by 2. So therefore, 1 by root 2 pi sigma integration of mu to mu e power minus 1 by 2 x minus mu sigma whole square into dx. So both the values we know that 1 by 2 minus 1 by 2. That is the simplification of the both the values. My 1 by 2 minus 1 by 2 is equal to 0. Mu is equal to m is equal to median. Hence for the normal distribution, so mean is equal to median we are taking here. Then one remark here. So the normal distribution is in symmetrical. Symmetrical since the mean, median, and the mode of the code coincide of the normal distribution. That mean is equal to median is equal to why mean is equal to median is equal to mode. The value is we are finding that the value here 0. See here, there is a 1 by 2, 1 minus 1 by 2 is equal to 0. Also so therefore, mu1, mu2, mu3, 5 is equal to 0. Mu2, mu4, mu6 also 0. So therefore, the conditions are satisfied. So therefore, mean is equal to mode, median is equal to mode. Moment generating function of normal distribution. What is the moment generating function? What is MGF? What is MGF we are taking here? If x equivalence n mu comma sigma square, then the moment generating function is x is defined as m of x of t. Moment generating function low mx of t is equal to integration of minus infinity to infinity e power tx of f of x dx. So where f of x dx? So where f of x? Where is the f of x dx? What we are taking here 1 by b minus a. So 1 by b minus a, that is the basically condition f of x. That is the probability density function is a normal distribution here. So therefore, f m of x t minus integration of minus infinity e power tx into 1 by root 2 pi into sigma e power minus 1 by 2 x minus mu whole square by dx. Let us use the transformation. x minus mu by z. Already we know that x minus mu by z. So the x minus mu is equal to z into sigma. We are cross multiplication we are doing here. So therefore, the derivative dx is equal to getting dx is equal to sigma into what is sigma dz? So sigma is the constant. So therefore, we are taking a dx is equal to sigma dz. So therefore, m of x t is equal to 1 by root 2 pi into sigma integration of minus infinity to infinity e power t of mu plus of sigma z and e power of minus 1 by 2 z square. So we are writing the values from the above steps here. Sigma get cancelled here. Dx means sigma dz, sigma get cancelled. Is not in the root. I already told you. So 1 by root pi into integration of minus infinity to infinity, minus infinity to infinity, e power minus 1 by 2 z square plus what is the values we are taking here? Plus t mu plus t mu. We are multiplying the e power t mu. Both the bases are same. So that's why we are taking the both bases are same minus 1 by 2 z square plus t mu plus sigma tz into dz we are taking here. So see here e power mu t under root of e power mu t I'm taking that is the common here 2 pi integration of minus infinity to infinity e power minus 1 by 2. So I'm taking the common of minus 1 by 2 here z square minus 2 sigma tz. అంటే ఏం చేస్తున్నాం మనము అందులో మైనస్ 1 by 2 కామన్ తీసినట్లయితే మన అంటే అక్కడ కావాల్సిన సిగ్మా వాల్యూ మ్యూ వాల్యూ రాసుకొని ఇక్కడ సింప్లిఫై చేసాము డైరెక్ట్ గా. సో దెన్ e power mu r 1 by 2 sigma square r square by root 2 pi. So integration of minus infinity to infinity e power minus 1 by 2. So that is a z square minus the 2 sigma z low z minus 80. So z minus 80 తీసుకుంటాం z minus 80 అంటే ఇంకో z ఇక్కడ నుంచి తీసేద్దాం. సో దేర్ ఫోర్ ద వాల్యూ ఇస్ dz. సో ముందు తీసుకొచ్చాం అన్ని వాల్యూస్ ని మనం. సో e power mu t plus 1 by 2 sigma square t square under root of 2 pi into integration of minus infinity to infinity e power minus 1 by 2 m square into dz, not dm, dz here. So therefore, e power mu r plus 1 by 2 sigma square t square by root 2 pi. This is the integration of minus infinity e power minus 1 square by m square తీసుకున్నాం కాబట్టి dm తీసుకున్నాం ఇక్కడ good. The m condition of dm తీసుకున్నాం both root pi get cancelled here. Therefore, m of x of t is equal e power of mu t, that is 1 by square sigma square t square. This is the moment generating function of normal distribution we are discussing just right now. Again we are discussing this is the part the same. This is the required MGF for the normal distribution. But the differential equation with respect to t. So put t is equal to 0. So automatically we have to differentiate equation. Put t is equal to 0. D by dx of mx of t. D by dt of e power of mu r plus 1 by 2 sigma square r square we are taking it. So mu1 dash is equal to mu1 dash is equal to m of x dash into t. So the mu central moment load and mu m dash of xt is equal to u mu t plus 1 by sigma square r square plus formula rastunam then simplification of mu into 1 by 2 sigma square into 2t. So 2 get cancelled here. So therefore mu plus sigma square by t. So therefore put t is equal to 0. What is the value I'm applying here? E mu of 0. R is equal to t is equal to 0. What they are applying in the condition here? Mu t place of 0 substitution 1 by 2 sigma square 0. Then mu plus sigma square t place of 0 substitution. So e power 0, the value is 0. Then mu plus 0. So both the values of e power 0 is 0. So e power 0 is e. Mu plus 0 is mu. So mean is equal to mu. So there is no change the value in the mu. Again, mu double dash x is equal to mu 2 dash is equal to d by dx of m dash x t is equal to 0. So in this condition, we are taking the double derivative, second derivation part. The second derivation part we are taking here d by dt of mu of t plus 1 by 2 sigma square t square plus mu into sigma square t. That is the value. What is the values applying here? That is equal to 0 here. So therefore, put is equal to 0. E power 0, mu t into under 0, mu plus 0 plus mu plus 0 plus e square 0. So mu 2 dash is called mu 2 plus sigma square. Variance mu 2 is called mu 2 dash minus mu 1 square. So that is the value mu square plus sigma square minus mu 2. Mu square square get cancel variance is sigma square. అంటే what mean అంటే mu వచ్చింది, variance అంటే sigma square వచ్చింది. అంటే sigma square ఎలా వచ్చింది, mu ఎలా వచ్చింది, moment generating function ఎలా find out చేయాలో we have learned. Clear? Any doubts?
No, sir.
Clear? Any doubt? Okay. Okay. Good. Additive property. Tomorrow we can discuss this one. Okay. Additive property. Additive property we can discuss tomorrow. Additive property 2.6.1 and discuss these problems also in tomorrow. Just 2.6.1 listen. Any doubts tomorrow? This is the most important theorem in the examination also. All of you understanding?
Yes, sir. Yes, sir.
Two independent random variable. Yeah. Sum of two random variables also follow the normal distribution. X equivalents to n, that is mu1 sigma 1 square. So y equivalents to n, y equivalents to n, mu2 sigma 2 square. Then it's a probability density function is given by, so f of x is equal to 1 by root 2 pi into e power minus 1 by 2 x minus mu by. అంటే ఇక probability density function అంటే రాసేయాల్సిందే. x f of x 1 by root 2 pi sigma root లో ఉండదు, e power minus 1 by 2 x minus mu by sigma whole square రాయాల్సిందే. See here, the moment generating function mgf normally distribution is given by m of x of t. M of x of t is called e of mu of t plus 1 by 2 sigma square to t square. So in this condition, what we are taking here, x equals to n mu1 comma sigma 1 square. So therefore m of x of t, e of mu1 of t, అంటే అక్కడ m ప్లేస్ లో mu1 of t తీసుకుంటున్నాం ప్లస్ 1 by 1 sigma 1 square t square. 1 ఉంటే 1 తీసుకుంటున్నాం, 2 ఉంటే 2 తీసుకుంటున్నాం. చూడండి ఇక్కడ y ఈక్వలెన్స్ టు x ప్లేస్ లో mu1, y ప్లేస్ లో mu2 తీసుకుంటే myt e power m mu2 plus 1 by 2 sigma square, sigma 2 square and t square. Clear? Any doubts? Now also the sum of two independent random variables x plus y. Random variables what we are taking x plus y we are taking here. So then mgf moment generating function we are taking here m of x plus y into t. So ఇక్కడ ఏం రాస్తాము, m of x plus t అంటే ఏం రాస్తాము, e of t కామన్ ఇస్తే x plus y రాస్తాం. రెండు కలిపి రాస్తున్నాం కాబట్టి మల్టిప్లై చేయండి, e of tx plus ty సపరేట్ చేయండి, సపరేట్ చేస్తే మల్టిప్లికేషన్ అవుతాయి. e power of e small e into t power x plus e into small e power y ty. That is first one m of x and m of yt. So therefore we are taking e power mu1 t plus 1 by 2 sigma 1 t square into e mu2 t 1 by 2 sigma square r square. So m x plus y t e power mu1 plus mu2 into t plus 1 by 2 sigma 1 square plus sigma 2 square into t square. This is the moment generating function of the normal variable. The sum of two independent random variables also the same normal distribution. Any doubts? Ask me. Hello?
No doubt, sir.
So this is the most important theorem, 2.6.2. We can discuss tomorrow class. Okay?
Okay, sir.
Okay. Manjula and another ones.
Thank you.
Okay. All of you understood these two first of second unit discussion, second unit important questions. Tomorrow I will tell you. Thank you.
Yes, sir. Thank you, sir.
Right, Amma. Hello? Anyone asking the doubts? No? Petko music even. Any doubts, Ash? Shweta and another one. Hello?
No, sir.
Okay.
No, sir.
Tomorrow we will meet at 6 o'clock and any doubts you can ask me and I will clarify.
Okay, sir. Thank you, sir.
Thank you.